This presentation is about different kinds of intermediate systems. As you can see when you take a look at the OSI model, N systems implement all layers. However, intermediate systems only implement a part of the layers. There are relatively simple intermediate systems which belong to the physical layer. A repeater has two interfaces and amplifies signals that it receives on one interface and sends them on the other interface. A repeater with several interfaces is called a hub. If a hub receives a signal on one interface, it amplifies the signal and sends it on all other interfaces except of the input interface. Therefore, repeaters and hubs increase the physical network size, but they cannot separate traffic. On the data link layer, we find bridges or switches. If a bridge has many interfaces, then it is called a switch. Nowadays, most of the time, switches are used so that I'm using just this word in the following. A switch can buffer data units and can decide on the forwarding based on addresses, in reality based on MAC addresses. If a data unit should be sent to one attached device, it is only forwarded to this device and not to other devices. As a consequence, this allows for parallel communication. Bridges and switches implement the OSI layers 1 and 2. As explained before, they belong to the OSI layer 2, but they need to use the services of layer 1 to be able to communicate. The device type router belongs to the network layer. The router is used to connect independent networks. To decide about the forwarding of data units, it uses IP addresses. The use of a router allows implementing security measures, that is, to enforce rules which kinds of communication are allowed or not allowed. A router implements the OSI layers 1, 2, and 3. For completeness, another type of intermediate system, the gateway or proxy, should be mentioned. A gateway implements all 7 layers. However, if there is such a gateway, this is obvious to the N systems because the gateway splits up the communication between the N systems.